This is section 8.4, adding and subtracting radical expressions. This is essentially combining like terms. If you have exactly the same radical and exactly the same variables raised to exactly the same powers, so if all of that is the same, you can add or subtract the numbers in front of the radical. Okay, so and all radicals must be simplified. So we still have to do what we were doing in the last section, and now hopefully we're going to be able to combine some things to make it a little bit nicer. Okay, so let's look at 4 times the square root of 3 minus 7 square root of 3. This is in the same pattern as 4x minus 7x. We just happen to know what our x values are here, okay? And so right here, what I would do is 5 minus 7, and I would get negative 3x. The same thing happens here. I keep this square root of 3, and I combine the numbers in front. 4 minus 7 is negative 3, and then I have that square root of 3. You should be able to see that it's the same pattern. It's just in this case, we happen to know what our x value is. That's the only difference. Okay, so this is the basic idea. This is the new part, okay? The rest of this is remembering how to simplify and then doing this step if possible, okay? So we want to simplify first. I have the negative square root of 48, negative 2 times the square root of 48, plus 3 times the square root of 75. Right now, in this format, these are not the same, so I cannot add them. But chances are that these two values will simplify. Now, what I'm bringing over is the same sheet we were using in the last section to get prime factorizations, and we need the prime factorization of 48, and we have it right here. This is 2 times 2, so that's 4 times the square root of 3. So what I have right here is negative 2 times 4 square root of 3. Okay, plus 3 times. I need the square root of 75, and I glanced through here real quick, and I don't appear to have it. So 75 is divisible by 3. And that gives 25, which is divisible by 5, and you get 5. So I have a pair of 5s right here, so that's going to be 5 times the square root of 3. So 3 times 5 times the square root of 3. Okay, now we can multiply the numbers in front. Negative 2 times 4 is negative 8 times the square root of 3, plus 3 times 5 is 15 times the square root of 3. Now, negative 8, now I do have the same radical, and this isn't going to happen every time, but it does happen a lot in this section because that's the type of problem they want you to practice. But I do have the same radical here, so I can combine negative 8 and 15 to get 7 times the square root of 3. And this is your answer. Okay, remember that your calculators can do some of these, and they will do the adding and subtracting too, but we still have to know how to do it by hand because, for example, it will not do fourth roots, it won't do large square roots. But in some of them, you can do negative 2 times the square root of 48, make sure you get out from under the radical, and hit plus 3 times the square root of 75, and it should give you your answer as 7 square root of 3. Okay. So let's try this one. These are both fourth roots, so it is possible that we are allowed to combine these, but I do need to simplify. 2 is prime, so this one's not going to simplify at all. But 32, we're looking for a fourth root of 32. If I look at this sheet that we had before, you can see there's a 32 right here. So if I cover up that 64, I have the prime factorization of 32. Now it's a fourth root, so I'm looking for 4 of a kind. Here I have 4 2's, so a 2 will come out, and I have a 2 left over. Looking for 4 of a kind, so I have 4 2's here, and then 1 more that's stuck inside. So this is equivalent to 2 times the fourth root of 2. There's nothing to multiply with here, so it's just the simplification. And we said the second one cannot simplify. So I have 2 times the fourth root of 2 plus 3 times the fourth root of 2. I have exactly the same kind of root, so I add the numbers in front to get 5 times the fourth root of 2. And again, your calculators can't do this. they can't give you the exact answer. You could plug it into your calculator. You get an ugly decimal here. You can find the ugly decimal here, and they should appear to be the same ugly decimal. That will tell you you haven't made a mistake. It will not tell you that you have simplified far enough. So, I mean, it's a way of checking to see if you've made a mistake, but it won't check that you have the correct answer. I hope that makes sense. All right, so let's go on. Let's simplify, or let's add 5 times the square root of 8 plus 3 times the square root of 72 minus 3 times the square root of 50. So this is going to be 5 times. All right, the square root of 8. I have 8 right in here. It's a square root, so I'm looking for 2 of a kind. So I'm going to have a 2 and then a leftover 2. So this is 2 times the square root of 2. Plus 3 times the square root of 72. So I glance through here to see if I have 72 anywhere, and I don't think I do. So 72 is divisible by 2. Okay, and you get 36. And then if you divide that by 2, you get 18. And then divide that by 2, and you get the 9, and then 3, and a 3. We are looking for square roots, so I have a pair of 2's here, a pair of 3's here, so that's going to be a 6 times the square root of 2. Minus 3 times the square root of 50. Here I have 50 right here, and it's 5 times the square root of 2. I think you're probably beginning to see the advantage of doing all these prime factorizations neatly so that you can reuse them. We're not having to do a whole lot of more work here. And the more problems you work, the more examples you're going to have, and then overall the less work you'll end up needing to do. So let's multiply here. That's going to give me 10 times the square root of 2 plus 18 times the square root of 2 minus 15 times the square root of 2. So I have a square root of 2 in all of them, and that means I'm going to be able to combine these. 18 minus 15 is 3. 3 plus 10 is 13. So this is 13 times the square root of 2, and that should be your answer. Okay, so let's do 4 times the square root of 50 plus 3 times the square root of 12 minus 5 times the square root of 45. Well, we just did the square root of 50. We just figured it out right here. It's 5 times the square root of 2. So this is 4 times 5 square root 2 plus 3 times. Do I have 12 on here? Yes, I do. It's hidden right in here. So that's 2 times the square root of 3. Minus 5 times the square root of 45. I have right here 3 times the square root of 5. Multiply the numbers in front. That's 20 times the square root of 2 plus 6 times the square root of 3 minus 15 times the square root of 5. Now, we're allowed to combine things if they have the same radical, and I don't have any radicals. This is my answer. I can't combine it. This is the same kind of idea as having 20x plus 6y minus 15z. These three variable values are not the same, so I'm not allowed to combine them. I wouldn't be allowed to combine this if this were the format either. Okay, the next problems, we're going to learn how to deal with variables in here. It really doesn't make it any more difficult. We just need to simplify here.